Today we are going to solve the problem 2.1 and 2.2 of Griffith 4th edition Introduction to Electrodynamics. The problem 2.1 consists of four parts. We will solve one by one. A is 12 equal charges Q are situated at the corner of a regular 12-sided polygon. For instance, one of the each numeral of a clock face. What is the net force on a test charge Q at the center? So, consider this as a clock. You have a charge at the center Q. This is 12 o'clock. This is 6 o'clock. Each arms we are keeping one charge Q. Here it is 8. So you consider the time 2 and 8. In 2 and 8 you have equal charge Q. So there is a net force towards the center. Here also net force towards the center. Both are equal and opposite. So naturally there are 6 pairs. Each pairs cancel their force each other. So total force will be equal to 0. Then section P is, suppose one of the 12 Q is removed, say the one at 6 o'clock. What is the force on Q? Explain the reasoning. So now let us take, I am removing the charge here. So all five pairs cancel their force each other. Only the 12 o'clock problem, because there is no opposing force for this. So that force between 12 o'clock and the center will not be compensated. The force between the 12 o'clock and the center is equal to capital Q, test charge multiplied by this charge over 4 pi epsilon naught r squared and r cat along the r direction. Section C is, now 13 equal charges Q are placed at the corner of a regular 13-side polygon. What is the force on test charge Q at the center? You have a test charge. Like section A, here also, due to symmetry, there is a rotational symmetry. Whatever way you rotate, you will get the same thing. So, due to rotational symmetry, the force at the center is 0. So, I can explain still in a better way. So you can take this charge and you take a line that is ports along through the center. It will go like this. I have shown in blue color. Then same thing I have given in saffron color. So this is at this point start here and it comes through the origin center. I mean it will go like this. So if you consider the blue line, there is two charges symmetrically situated. Here also two charges symmetrically situated. So each will cancel out. Even if you rotate, same thing will happen because of the symmetry. So with physical justification, we proved F is equal to 0 for three-sided polygon. So what will happen if one of the 13 Qs is removed? What is the force on Q? Explain your reasoning. Same thing as I explained in section P. Let us say I am removing this charge. Better I assume this I am removing charge. There is no charge to compensate this Q. Only this Q, where I removed that charge, there is no compensating charge. So there will be force between this charge Q and the test charge capital Q. So force is equal to capital Q multiplied by small q over 4 pi epsilon r squared r cat. So we have proved all the four. And now we will solve the problem 2.2, that is find the electric field, both magnitude and direction a distance z above the midpoint between equal and opposite charges, that is plus or minus q, a distance t apart, except as same as the example 2.1, except that the charge at x is equal to plus d by 2 is minus q. In the earlier, in the example 2.2, both charges are equal. Here sign is different. So you take positive x direction. This is d by 2, and the charge kept at this point is minus q. So similarly, the other side, the positive x, negative x-axis, this distance is d by 2. It's actually is a dipole. Its charge is q. Now we can see the electric field. Electric field along this direction is E1. Let us say this is E1, and this electric field due to negative charge is E2. So you have parallel and perpendicular component. Now perpendicular component due to E1 is it's upward. It is upward, or maybe I will use different color. It is upward. Electric field is upward. That is perpendicular component. Due to the minus q is downwards. So the perpendicular component cancel each other. Only the parallel component exists. So parallel component along this x direction exists. So the electric field is equal to E is equal to E1 plus E2. So E1 we can take that as q over 4 pi epsilon not a script r1 square. This is, let us say this is a script r1. This distance between the plus q and this charge point under consideration. This point is p. Let us say this is p. Similarly, the distance between minus q and p, point p is script r2. So now E is equal to q over 4 pi epsilon naught script r1, this distance, script r1 square along the direction r1 cat, along this direction. Similarly, E2 is minus q, because here charge is minus q. So minus q over 4 pi epsilon naught script r2 square r2 script r2 cat, that is along direction r2. So now you can take q over 4 pi epsilon naught outside, because 4 contain q by 4 pi epsilon naught. So then remaining term is r1 cat over r1 square minus r2 cat over r2 square. Then by definition, the vector script r1, you can see this arrow. So along the r1 direction, script r1 direction is equal to the magnitude script r1 multiplied by the unit vector, that is direction along r1, that is r1 cat. So this is unit vector. So naturally the r cat unit vector is equal to, in this case unit vector is equal to r that is the vector along the r1 direction, that is arrow indicate the vector along the direction script r1 over the magnitude of r1. So you can see this can be replaced by r1, that is, this indicate the direction, not the unit vector, along the direction script r1 over here already you have r1 square, script r1 square. Here you have one script r1. So this will become a script r1 q. Similarly this one, R2 over script R2 cube. This is the vector. R1 and R2 are the vectors. Now we will see further. Now we got this expression. E is equal to Q over 4 pi epsilon naught R1 over R1 cube minus R2 over R2 cube. Here R1, R2 are the vectors. So now you know the script R1, this distance. Script R1 is equal to this T by 2. This distance is, of course, T by 2 from the origin, T by 2. This is Z from this to point P, from middle to point P. This Z. Now this script R1 is equal to T plus 2 whole squared plus Z squared. So T by 2 over T by 2 squared plus Z squared. Similarly, what is script R2? So script R2 is this one. Let us say this is script R1 is along positive x direction, script R1, which is equal to, you have to subtract this. This is from origin minus T by 2. If you move the distance minus T by 2, then you will reach the origin. So the script R2, sorry, this is not R1, this is R2. Script R2 is equal to square root of minus T by 2 whole squared plus Z squared. Anyway, T by 2 minus T by 2 whole squared will become T by 2 whole squared. So script R1, script R2 are the same. So you can take out, that is script R1 and script R2 is equal to script R. So I am taking it out. So you have to cube this. Then this will become Q divided by 4 pi epsilon naught T by 2 whole squared plus Z squared power 3 by 2. Because it's a square root, you have cube, so 3 by 2. Of course, we have this difference. The direction of script R1 minus script R2, this difference. So what is script R1? Vector script R1. So here you are taking the vector quantity. Then you have to add these two. For negative x direction, you add this. Okay, I will use different color. You add this and this. Maybe sorry, I will use different color. I can use green color. We can add this and this vector. That is very important. Sorry, for finding script R1, we have to add this and this Z. So you have to add. So if you add, this is T2 T divided by 2 along x direction. So I have mentioned that T over 2 along x direction, and this is Z. Z along Z direction. That is Z cat. Similarly, the other one, script R2. So you can subtract. Here it is minus. To reach the origin, you have to subtract T by 2. So then you have to add both. That is minus T over 2 along x direction plus Z along Z direction. So then you will get, which is equal to, so now you have to add these two. Sorry. So now you have to find the difference. Now you can see this Z cat will get cancelled with this minus Z cat, because there is a negative sign outside. Then here you have one minus. Minus of minus will become plus. So T plus 2 plus T plus 2 will become just T, but along the x direction, x cat. So I have mentioned the x cat. So I have replaced this as t along x direction, tx direction. So tx direction, I replaced this by t along x direction. I have kept the denominator as it is. So now we will see some more detail about this. So now we got this expression E is equal to QD, that is dipole moment, over 4 pi epsilon naught d over 2 whole squared plus z squared whole power 3 by 2. Now let us say the z is very much greater than t by 2. So you are considering along long distance, then naturally this will get neglected. So you will get z squared power 3 by 2, which is zq. Exactly same as electric field in the dipole. So thank you very much for watching my video and supporting me continuously. Thank you very much.